All right, this is the video 12A intro to review slides for week 12. The topics for this week are going to be fundamental forces and atoms. There are assignments this week. There is the homework assignment. There is also the notebook check that's on the homework assignment. And there's the fundamental forces lab activity that's due Friday at 11:59 p.m. All those can be found on Google Classroom. The announcements, Mr. Cardozo will not be here Friday, April 9th and Monday, April 13th, but everything will be on Google Classroom that you need in order to get those done. There are no office hours because we are now back to 5 days a week. The big question for today, I never put anything on the first one just because I always put Isaac Newton up there because he did his best work during quarantine. Now, the weekly plan is I would like to have Monday to be like an introduction to what we're learning that week, notes, videos. Tuesday is going to be the first lesson. Wednesday, just the second lesson, just to go over that, and then just have a lab day on Thursday, and then Friday just miscellaneous and homework. And these can be rearranged as needed, but that way it gives everybody a lot of time to take notes, get the assignments done within class. Now, every week there will be a lab activity, a homework assignment, and you do need to watch all 3 videos with those codes and a notebook check that is also on that homework assignment. So that is the weekly task list. Just watch the videos, do the notebook check, the activity, and that homework assignment should come last. And remember, there's always going to be 2 codes in each video. One's a written code, one's a verbal code. Each will be 3 numbers. You will need these codes in order to move on with that homework assignment. So let's review what we did. So we learned about ramps last week, and we did it's all uphill simulation, and we answered these questions. The angle of the ramp didn't affect the gravitational potential energy. This is the data that you should have gotten for that lab. And notice that as the angle of the ramp increases, the force increases, but the the displacement decreases, right? So why does Ben Davis have stairs instead of ladders? Well, it's because you apply less force. That's what ramps allow us to do. So if we're looking at the ramps off to the right, notice that I like to think of it as trading it in. So if I don't want all this force, I can just trade some of that in, but I have to get more distance. So notice that one with a longer ramp, but it's going to be at a 30-degree angle. So you're going to apply less force, but larger distance. And as that displacement goes down, you have a larger force. That's what roads do. So roads or roads going up mountains, these switchbacks, that's like an extended ramp. So you apply a smaller force for a larger distance. So we talked about the Colorado Mount Evans Scenic Byway, and notice that it switches back. It's the highest paved road in all of America. And notice that you don't have to apply that large of a force because it's only going up about it's only an angle of about 2.8 degrees, and you're going 28 miles. Now, if you go to Canton Avenue in Pittsburgh, Pennsylvania, well, it has an angle of about 20 degrees. You're going to apply a lot larger force to get up that short displacement. Right? So those are the links for that day. And then the next one we asked, why can't you jump over the top of Mount Everest? And we learned about power, right? So power is just a ratio of work done to time taken. It's how fast work is being done. And the unit is watt. So if you apply 1 Newton, 1 meter, 1 second, then you'll have expended 1 watt of power. So you've probably seen power or the watt in light bulbs, right? So the higher the wattage, the brighter the light bulb. And so we talked about who won the stair challenge. Well, what I did was I added the power column. So I have all the different ones. Now notice that in some of them, well, the fastest did the most work and exerted the most power. But sometimes these aren't mutually exclusive. If you go the fastest, you might not have done the most power, right? You might have done less work, right? So sometimes there's a 3-way, split. Like if I said who's the fastest, that was a different winner than who did the most work, and that was a different winner than who did the most power. Right? So these are the winners throughout it. But notice that most of the time, Mr. Cardozo did the most work because, I exerted the larger force by going up the hill. Now, why can't you jump to the top of Mount Everest? Well, I always like to think like we consume 2,000 calories a day. That is a unit of energy. Now, a single calorie is enough to increase the temperature of a liter of water by 1 degree Celsius. 1 calorie is 4,184 joules. So, if you were to convert all of that energy into gravitational potential energy, you could jump to a height of 8.4 miles. I would put you at a height. That's you, gravitational potential energy. Now, Mount Everest is 5.5 miles above sea level. Now, why can't we jump to the top of Mount Everest? Well, it does seem like a silly question, but you do have the necessary chemical potential energy in your body to complete that feat, but your muscles just can't convert energy fast enough. They don't have enough power. So that was then we had the Big Mac challenge where we calculated how long it would take us to burn off a Big Mac by bringing it up to our mouth to eat it. So this is how long it took. These are the winners in each class. So notice like about a little over 1 week is kind of the standard for a really fast time. Sometimes some people got over 2 weeks, depending on how fast. But if you were to just continuously apply that force, do that work repeatedly, you eventually would burn off Big Mac. And the key to this was that you probably want somebody with longer arms because with every rep that they were doing, they would do more work. All right, and those are the links for that day. And the video 12A written code is 516. I would write that down somewhere. So what are we learning about this week? We're learning about fundamental forces of the universe and atoms. This is a nice video on the fundamental forces. This is a video on the atoms. And right now I'm going to give you the verbal code. Verbal code for 12A is 469. I say that again, the verbal code is 469. We're going to do a build an atom simulation where you build atoms. Then we're going to do the gold foil experiment. We're going to recreate Ernest Rutherford's famous gold foil experiment. Those are the links for today. And this is the final thought. Remember, there's too much unknown in the universe to take a break from learning. Get out there and question everything.